All right, folks, we're going to talk about some more types of trigonometric equations. These are all listed in the slides in section 7.5. I'm not going to display the slides. I'm just going to do them here on my whiteboard. So we're basically going to do a few little techniques to work through some of these equations. Last time we described how if there's just one type of trig function, you can do a u substitution to solve for it and then work out the angle. So it's going to be the same idea here as last time. It's just we might need to do a little more work on the front end to get it to the right form. So for example, the first equation here looks like this. 1 sine theta plus 2 cosine squared theta, or 1 plus sine theta equals 2 cosine squared theta. Now the problem is we've got both a cosine and a sine. So we should be able to use our favorite identity to get rid of those cosines. Let's just change this to 2 1 minus sine squared theta. So now, setting the left and right equal, I mean they're already equal, we'll just skip that middle part. 2 minus 2 sine squared theta. Let's make the substitution u equals sine of theta. We plug that in. 1 plus u equals 2 minus 2u squared. Now, this is a quadratic. Now, again, you are expected to know how to deal with quadratics. That was in a prerequisite to this course. Feel free to come by office hours sometime if you want to review some of those techniques, but we're not going to have time to go over them in class. So, let's move everything to the other side. 2u squared plus u minus 1 equals 0. So we factor this as 2u minus 1, u plus 1 equals 0. So this splits into two different solutions. 2u minus 1 equals 0, so u is 1/2. And u plus 1 equals 0, so u is negative 1. All right, so that means this also splits into cases. See, once we've solved for u, we then back substitute. Sine theta equals 1/2, or sine theta equals negative 1. So now that we have that, we can solve both those separately. Think of the unit circle. For 1/2, in the unit circle, it's either pi over 6 or 5 pi over 6. And for negative 1, it's 3 pi over 2. Or if you use negative pi over 2, that works just as well. So then we can say, what are the solutions? Well, that's theta is in this set pi over 6 plus 2n pi, 5 pi over 6 plus 2n pi, 3 pi over 2 plus 2n pi, comma, where n is an integer, n is in z. And I also use the in symbol, the epsilon there, because, writing an equals there would technically be not right, because it'd be saying theta is equal to that whole set, when in fact we're just saying theta is anything in that set. If you did write theta equals the set, or if you just wrote the set, I would still give credit for that, but, this technically set theory notation should be written in that form. But I don't want to worry too much about that. I think it's not that important at this level. So, on the next page, you will see, it says on your own, OYO for on your own, 2 sine squared theta minus cosine of theta equals 1. And I'd encourage you to pause and try to work this one out for yourself, and then I'll show you the answer. So, we'll do the same trick as before, but we'll change the sine squared into 1 minus cosine squared theta. And so then this time u would be cosine, not sine. I suppose you could try to change the cosine into a sine, but there would be a square root involved. So usually we're looking for sine squareds or cosine squares because those are easy to switch back and forth. So if we plug that in, then 2, 1 minus u squared minus u equals 1. And if you work out the, that looks like an A. If you work out the algebra, you actually get the same quadratic as before. It factors again into 2u minus 1, u plus 1 equals 0. So that means this time its cosine is either half or negative 1. And so we split into those two separate cases. If cosine is 1/2, then on the unit circle, well, it could be pi over 3. But, okay, well, it's technically not on the unit circle, also negative pi over 3. So I'm just going to put plus or minus just to make it a little more compact. And over here, where is cosine negative 1? That's at pi. So the solution set would be plus or minus pi over 3 plus 2n pi, comma, pi plus 2n pi. And there are often other ways to write it. Sometimes the two different types of answers can be written in as one, like just a single expression. What I will say is that I would not take off points if you accidentally put too many answers in here. If it was like you wrote the same thing twice, that's fine. Technically, with a set, nothing's supposed to appear more than once. But if you accidentally, if you write like pi plus 2n pi, or pi plus n pi, and 2 pi plus n pi, that would be redundant. But it would not have anything wrong in it, so I would not take off any points for that. All right, let's look at the next one. So, cosine of 2 theta. And if I didn't mention earlier, these notes are on the Canvas shell, section 7.5. The problems are. I'm just showing all the solutions, same as if it were a regular class. So, the fact that there's a 2 theta and a theta here is not good. It's really not any convenient way to solve a problem like that if they have different arguments. This one has 2 theta, this one has a theta. So we'll split this one up using the double angle formula. This is cosine squared theta minus sine squared theta equals 3 sine theta minus 1. Well, now we always want to say we want to have only sines or only cosines or tangent or whichever other one it is. We only want one type. So let's change that cosine into the cosine squared, into 1 minus sine squared. So then we can do the u sub. U would be sine of theta. So 1 minus u squared minus another u squared equals 3u minus 1. Then let's move everything to the right. And I get 0 equals 2u squared plus 3u minus 2, which factors into 2u minus 1, u plus 2. So that means u is equal to either 1/2 or negative 2. Well, we can strike negative 2 out right now because we can't make sine equal to negative 2. So this means we're really just dealing with u equals 1/2. So this is the same problem we've seen before. Sine of theta is 1/2. Excuse me. So then theta must be, let's see, what are options? That's in pi over 6 plus 2n pi, or 5 pi over 6 plus 2n pi, where n is an integer. Okay, let's do some more. I'm just going to keep rolling along. And by the way, I'm doing these by hand, and I've worked them out in advance, so I'm pretty sure they're all right. If It turns out I've made a mistake and someone in the audience catches it, please email me so I can correct it. Hopefully there aren't any. All right, so here I see a mix of cosines and sines. Now, in any of these problems, it's possible there's more than one way to solve it. In fact, I'd say there usually are, just because we've had so many identities. So maybe you have an idea that's different than mine, but my thought is, let's square both sides, because most of our identities, we like cosine squared and sine squared. So if we square both sides, we can make some squared functions appear. But as I said before, don't get intimidated if you don't see what you're supposed to do right away. The best thing you can do is just try something and hope that it works. And if it doesn't, that's no big loss. You just start over and try again. All right, so on the left, I've got cosines. On the right, I got sines. Now, the cosine squared to sine squared could both be changed into the other one using our identity, but that regular cosine is really not much we can do with that. So instead, we'll change the right side to be 1 minus cosine squared theta. So now we've got all cosines. So we'll sub in u is cosine of theta. Now we'll go u squared plus 2u plus 1 equals 1 minus u squared. Move everything to the left. 2u squared plus 2u. Oh, minus the 1 zeroes out. So it just equals 0. Oh, that makes it even easier because we can just factor out a 2u. All right, so u is either 0 or negative 1. So when does cosine equal 0? Well, that would be at pi halves or 3 pi halves on the unit circle. We'll just solve it on the unit circle and then add in the 2n pi at the end. When does cosine of theta equal negative 1? Well, that's straight down on the unit circle, so that's... No, it's left on the unit circle, so that's pi. So now you could write each of these and just put a plus 2n pi at the end. You could also get a little sneaky here if you notice these. Well, actually, hold on a second. What does the solution say for this one? Sorry, let me make sure I've got this right. I think this one might have said, let me double check the notes on this one to make sure I think I might have left something off. Give me just a second. Section 7.5. Yeah, sorry, this one just says solve in the interval 0 to 2 pi. Okay, so we don't need the 2n pi. So we only need to list the ones that are in the main interval. So that means theta has got to be instead of either pi halves, pi, 3 pi halves. But if we were asked for all solutions and not just the ones in that interval, then yeah, we would include the plus 2n pi on all those. Okay, so next problem we have is similar. This is sine theta minus 1 equals cosine theta. So I'd do the same thing. Give this a try, but I'd square both sides. And then the first thing I remember trying is I subtracted the sine squared theta, get cosine squared theta minus sine squared theta, because I was thinking that could be cosine of 2 theta. But then I realized that wouldn't actually help me any. So now I'm just going to change this right side to 1 minus sine squared theta. So then u is sine theta. So u squared minus 2u plus 1 equals 1 minus u squared. Solve this out, we get 2u squared minus 2u is 0. So again, almost the same thing. U is either 0 or 1. It's an equal sign there. So if sine theta is 0, well, sine theta is 0, if you think of a unit circle, at 0 or pi. That's for sine theta equals 0. And for sine theta equals, now that looks weird. And for sine theta equals 1, where is sine theta equal 1? Pi over 2, which is straight up. So what are the possible solutions? Now I could say 0 plus 2n pi and pi plus 2n pi. However, since they're 1 pi apart, you might notice it's just n pi. That includes all the whole numbers. 0 pi, 2 pi, 4 pi, and this is 1 pi, 3 pi, 5 pi, and so on. That covers all of them. That said, if you wrote 0 plus 2n pi and pi plus 2n pi, I would accept that. I'm just saying this is a way to save some paper. All right, next problem says find values for which sine of x and cosine x intersect. So we're talking about if we draw the graphs, something like that, then we'd say where they intersect. Well, that's where sine x equals cosine x. Now, maybe you can think of this on just, maybe you get this right away, but if you don't, what if we divide both sides by cosine? And that's the same as saying tangent is 1, or sine equals cosine, whichever way you want to think of it. But on the unit circle, here's a line of slope 1. And so these points here, that's where they're both root 2 over 2. The reference angle here is pi over 4. And since the period of tan is pi, we have to say the answer is, theta x is in pi over 4 plus n pi, where n is an integer. Okay, try the next one. Again, my advice is on your own problems to pause and try them on your own before looking at my solution. But 3 cosine x plus 1 equals cosine x minus 1. And that's just, you want to understand, whenever a question says where do two graphs intersect, you set them equal to each other. That means their y's are equal, and then you solve to find what the x is. So I'll say u is, u is cosine of x. Maybe you don't feel the need to do the u on this one because it's not too complicated, but if that's the habit we've gotten into, this becomes 2u, add 1 to both sides, plus 2 is 0. So u plus 1 is 0, u is minus 1. So you're not required to write the u sub if you don't feel you need to, since this equation is as complicated as some of the other ones. But it's the basic idea. Cosine x and negative 1. If you're not writing it out, you're kind of implicitly doing that. So whereas cosine of x equal to negative 1, my notes are weird, straight down, x is in 3 pi over 2 plus 2n pi, where n is in z. Did it give an interval on this one? I don't remember. Let's check. Oh, it says on the interval negative 2 pi to 2 pi. Okay, so we don't want all of these. So this is not quite right because we only want a certain number of intersections, certain number of points. So the interval we were given, our domain, I suppose, is negative 2 pi to 2 pi. So on this particular problem, this would not be the correct answer because it has too many answers. We only want ones that are in that interval. So it'd say, okay, well, 3 pi over 2 is in the interval. And I'd also say negative pi over 2 is in the interval. We took 3 pi over 2 minus 2 pi, we get negative pi over 2. And that should be all of them. Another way of thinking of it is on the unit circle. If you go forward 3 pi over 2, you get there. And if you go backwards pi over 2, you get there. But any other distance would either be too far or would not land at the right spot. Still, another way to think of it would be draw the graph of the cosine like that. Say, where does it equal negative 1? I am embarrassed because that was wrong, wasn't it? Oh dear, Let's rewind a bit. Maybe I'll edit this part out. Where does cosine equal negative 1? Oh dear. Cosine equals negative 1 over here. So that means it needs to be either pi or negative pi. Okay, so the solutions were, in fact, x equals plus or minus pi. I realized that when I was talking about it because cosine's an even function. So if I say, where is it equal to negative 1, it would have to be the same on the left and the right. And so, yeah. So, yeah, those are the answers, plus or minus pi. So, yeah. If you don't understand what I'm complaining about, it's probably because I edited out the mistake. And so, anyway, let's move on to the next one. All right, so the next one says, solve the equation of 2 sine 3 theta minus 1 equals 0. 2 sine of 3 theta minus 1 equals 0. All right, now this one's a little different than before, because now the weird function that we have to deal with is inside the sine. So let's do a different substitution. Let's say u is 3 theta. So then we can say 2 sine of u. So you can always substitute whatever you want, as long as you make sure to change back at the end. All right, so 2 sine of u is 1. Sine of u is 1/2. And let me check. What was our domain? Was it 0, 2 pi? Yeah. Notice there's parenthesis on the 2 pi, and that's generally because 0 and 2 pi are kind of like the same thing because they're a full circle apart. All right, so u is equal to pi over 6 plus 2n pi, 5 pi over 6 plus 2n pi. So that means 3 theta could equal pi over 6 plus 2n pi. We don't want 3 theta, we want theta. So let's divide by 3 on both sides. Which is the same as times 1/3. Theta would be pi over 18 plus 2n pi over 3. Let's make these have a common denominator. Pi over 18 plus times 6, 12n pi over 18. And then 2 pi, if we get it to have a common denominator, that's our upper limit, would be 36 pi over 18. So then, what is theta? Well, theta is then pi over 18, and we will add 12 pi over 18 until we're too big. So add a 12 pi over 18 would be 13 pi over 18. Add another one would be 25 pi over 18. Add another one would be 37 pi over 18, which is too big. Now what about the other piece? That takes care of that one. What about the other one? Theta is 5 pi over 6 plus 2n pi times 1/3 again, which would be 5 pi over 18 plus 12n pi over 18. Clear some space here. So we go through these. We have 5 pi over 18. Add 12, be 17 pi over 18. Add another 12, be 29 pi over 18. Now another 12 and we'd be too big. So theta, there are 6 solutions. That would be pi over 18, and you can write in any order you want to. 13 pi over 18. 25 pi over 18, 5 pi over 18, 17 pi over 18, and 29 pi over 18. So there are 6 solutions this time. And what that more or less means is that we've got that 3 theta here. It means that our function is moving 3 times as fast, so therefore it hits the target we're talking about 3 times more than it normally would. All right, try the next one. Looks similar, but it is a cosine instead of a sine. So it's 2 cosine of 3 theta equals 1 in 0 to pi. So again, because it's a times 3, I'm expecting there to be 6 solutions, since normally we'd only have 2 solutions. So I'll make the substitution. U is 3 theta. So I'll say 2 cosine of u is 1. So cosine u is a half, which means that u is pi over 3 or negative pi over 3. That's in the unit circle. And then I'll put the plus 2n pi there. So now I say 3 theta is plus or minus pi over 3 plus 2n pi. So divide by 3 on both sides. This becomes theta equals plus or minus pi over 9 plus 2n pi over 3, which then becomes plus minus pi over 9 plus 6n pi over 9. So that's half the answer. Let's see, was that? Oh no, plus or minus. That took care of both of them. See, in the unit circle, it'd be pi over 3 and 5 pi over 3. But by using a plus or minus, that means I don't only have to list one set of answers. I don't have to list them separately. All right, so now theta, if we're going to be from 0 to pi, that means we get the first one to be pi over 9. The negative pi over 9 will not count because we're supposed to be positive. Let's figure out what would 2 pi be. Let's get a common denominator. That'd be 18 pi over 9. So that makes it easier to count. All right, pi over 9. Add 6, since we got 6n pi, so 7 pi over 9. And 13 pi over 9. Like I said, we also got to deal with the negative. Now, negative pi over 9 is not in there, but if we add 6 pi over 9, that would give us 5 pi over 9. So Yeah, it's just negative pi over 9 plus 6 pi over 9 is 5 pi over 9. That's all I'm saying. And then we add another 6 pi over 9. We get 11 pi over 9. We add another 6. We get 17 pi over 9. And then after that will be too big, because I made a note here just so I know 2 pi of that here, so that I know not to go past 18 pi over 9. All right, we just got a couple more to take care of. So let's see. Root 3 tan theta over 2 minus 1 equals 0. And this time they gave us an interval of 0 to 4 pi. We got theta over 2, we're going slower. So I think I'm going to get 2 solutions again, because in 0 to 2 pi I'd expect 2. So I'm going half the speed, I expect half as many solutions, but I also have twice as big a window. So I think it'll work out the same way. All right, so tan theta over 2 equals 1 over root 3. I'll make the u sub here. Tan of u is 1 over root 3. So if we solve that, there's 2 solutions to this. This is, I can rewrite this. Like I said, I like to do this as dividing both by 2, so I can think of it as sine over cosine. So it would be over here is pi over 6. And then at the opposite side would be 4 pi over 6. So they're off by pi halves, so... Well, anyway, what are my answers? Okay, so my general solution here would be pi over 6 plus n pi. And that actually covers both of them, because they're a whole pi apart from each other. Though again, if you are pi over 6 plus n pi and 4 pi over 6 plus n pi and gave me both, it's redundant, but it's not wrong, so I wouldn't take off any points for that. So that's u. So now that means theta over 2 is pi over 6 plus n pi. So theta is pi over 3 plus 2n pi. Which looks like one of our normal type solutions there. So now we just need to list which ones are in 4 pi. Let's see, I'll rewrite this as pi over 3 plus 6n pi over 3. And 4 pi, get a common denominator, would be 12 pi over 3. So our answers then are pi over 3 and 7 pi over 3. All right, last problem. Cosine theta over 2 minus 1 is 0. So I'll solve that. Try it out on your own again as usual. But cosine theta over 2 equals 1. So u is theta over 2. Cosine of u is 1. So where's cosine equal 1? We'll be given a domain for this one. 0, 2 pi. Okay. So that means u must equal 0 or 2 pi or 4 pi, because cosine equals 1 would just be on the right. So in other words, u just equals 2n pi plus 0, but you don't need to say plus 0. All right, so that means theta over 2 equals 2n pi. So theta is 4n pi. So theta can be 0, 4 pi, 8 pi, 12 pi, but only one of those is in the interval. Theta equals 0 is the only solution to this one. And that about covers it. Go over this. Go over the Exam 2 review that's posted on Canvas. Be prepared for any questions on Monday's class. I will see you then.